Most of the room is full, so we'll get going. Good to see you. I enjoyed the keynote. That was excellent, wasn't it? Some good stuff from AWOUT. So we're going to talk about FHIR, general introduction to FHIR. So we'll take you from, I don't know, just the very word FHIR up to a few technical slides. 40 minutes, about 40 slides. Hopefully something for every level. I'm not sure if you guys are technical or clinical or experienced FHIR guys or not. So we'll see how it goes. Ask questions as we go along, that's fine. If you can't hear me or I'm too fast or too slow or too British or something, just stop me and say what's what. So that's me, Rick Smithies from the UK. I do some HL7 stuff with the UK committee. An email address there for me. So what is FHIR? So the whole day, the whole week's all about FHIR. So I guess you guys know something about FHIR. An electronic healthcare standard, interface standard. Of the bullets there, I suppose the key one is that it's meant to be simple. Yeah. So we've had healthcare exchange interface standards before. Going back many years. HL7 organization has been going some 30 years. Been in this business a long time. FHIR comes from HL7. FHIR is designed to be simpler and easier to get to grips with than previous versions of the standard. It's more modern, another refresh, so it has that. It has the new technology and so on. But simplicity is the kind of key thing, if you wanted one word. And then we have resource. So the third bullet there saying resources. So we'll talk a bit about resources. It's the R in FHIR, of course, fast health interoperability resources. And I suppose if you could say one thing about FHIR to just summarize it, it's about data resources and locations to keep and find those resources. So your chunks of data are resources, and then we have a web-based way of finding those resources. So that's kind of like the one-liner, resources and a place to keep them. And you can see the URL down at the bottom. It's a really nice, easy to browse standard. It looks like that over there. Lots of nice introductions and so on. And we'll see some screenshots from that as we go through. So I guess you know what it stands for, fast. When we say fast, we don't particularly mean bits per second fast. FHIR is quite small and compact. We like that, but the idea is it's fast to develop. So you could say quick, simple, straightforward. The idea is people can read the spec, understand it. You don't need to be a healthcare interoperability guru or with a master's degree, hopefully, to get to grips with it. And the idea is in a kind of a weekend, a couple of days working, you could get some code going. There's lots of example code and even software. You can download the code and so on, and examples in the standard. So fast to get to grips with. Obviously, it's healthcare. That's what we all do. Interoperable, yeah, it's about connecting system A to system B. And C and D and so on. You can use FHIR as your data inside your system if you like, but FHIR is primarily invented to be the glue between systems. So it's a kind of common language interfacing between your system and somebody else's healthcare system. And then resources. So resources are our chunks of data. There are kind of our nouns of healthcare, if you like. So we've got patients, encounters. They're the data structures and the classes that we operate with. And the word resource actually comes from a web-based way of working. So in the Restful web-based way of working, we'll mention REST a few times, it's a key thing with FHIR. This Restful way of working, your web pages and your endpoints of data are resources. So that's where that word resource comes from. It comes from that web-based way of looking at data. So it's not just a general word for some FHIR stuff. It has a kind of meaning in the kind of wider IT world for those of you who that might echo with. So FHIR, what's it trying to achieve? Well, the big one there in bold, implementers. So coders, hackers, whatever you want to call them. It's designed for people to, your technical guys to get to grips with it and get going with it quite quickly. FHIR is a bit of a reaction to the version of HL7 before this, HL7 version 3, which itself built on version 2. Version 3 was a nice theoretical, sort of back to basics and well-designed, well-implemented standard, but it proved difficult. You know, you had to kind of become a guru in version 3 to even get a simple thing going. So although it had some power, it became a little bit top-heavy and hard to use. Implementers looked at it and thought, what the heck is this stuff? FHIR deliberately goes back the other way, starts from the simple building blocks, chunks of XML and JSON that developers are used to seeing. So, you know, college kids, people starting with a little bit of experience, should be able to look at FHIR and, you know, start running with it. This is a key thing. Because we've built standards before that were not as usable and successful as we wanted. So we switched it around. Part of the aim, or part of the way of achieving that, is to limit what FHIR tries to cover in its core. So this 80% rule, FHIR tries to cover the most common 80% of use cases. Yeah. So if most systems, and we have to find a way of estimating this, it's not an exact thing, but if most systems out there currently use a certain feature or a certain aspect of the patient record or the condition record, then it goes into FHIR. If it's even a slight edge case, so you know 20% is not perhaps the small edge, but if a lot of systems are not doing it, then we don't put that in the core of FHIR, recognizing that some people will be missing their features, but it's almost as if the last 20% actually takes another 80%. You know, if we have your 20% and your 20%, before you know it, you've got something that's, you know, 180%. So we keep the core small, and we have a way of extending the core sort of afterwards. So it makes FHIR approachable and manageable. You know, you can read the stuff, find it familiar, and you won't find the Norwegian patient number there or the Welsh middle name or something that you're kind of not going to use on day one. So we use today's web stuff. You know, we use HTTP and XML and JSON. There's some bullet points on the next couple of slides, and FHIR. The one thing I'll mention a few more times is the Restful web hosting way of looking at FHIR data. That's the main way of working, but it also supports messaging. So this is sort of TCP/IP or, you know, bus-based messaging of chunks of data. You know, your institutions probably have these HL7 version 2 backbones already, integration engines and so on. You may want to put new style FHIR data traffic over your existing network. So FHIR supports other ways of working as well. And it's completely open in the sense of open source. You can get the source, you can compile it, you can do what you like with it, and it's free. So it's free as in free speech. You can do what you like with it. Free as in beer. It's cheap and free. Not just cheap, it's free. Yeah. So recapping a little bit, coders. It's written for coders to be able to understand. There is rationale and theory behind FHIR, but that's kind of, you know, hidden away. You know, we just hit you with the finished product, and, you know, the theory is not something that you need to get to immediately. Our resources, the actual UML and XML chunks, are relatively simple, manageable. The 80% rule helps with that. And there's tooling. So earlier standards, we would have spent a couple of years building the standard, and then you kind of present it to the developers and say, here it is. And they're like, okay, well, now you've given me 500 pages of stuff. You start coding, and then, you know, there's a big kind of delay, and also you can't get going on day one. So FHIR compiles the code that lets you work with FHIR in the standard. It's published the same time. In fact, it's published, you know, they're built from each other. So when the models are published, the code, the C# code, the Java code to manipulate those data items, they're already there. So it comes out as one integrated package. So that's really nice. Covers from some of your major languages, and people have extended it into Objective-C and Ruby and all sorts of other things. People like examples. You can give people a simple spec, but your average developer, he won't even read the spec. He'll just look at the example. He'll look at the JSON and go, I'll make one of those. I'll cut and paste that and build some code that just puts in the patient number and so on. So we realize that people don't even read even the simple documentation, at least not immediately. So we have our 80% rule. We know that if you only include the 80%, almost every use case in every hospital, that you will find that you have something that doesn't fit into the 80%. So this is a deliberate decision. The two ways of thinking about it are either we include everything, every use case from every part of the world in every specialty in every hospital. We tried that with the last one. It didn't work. Or you make a deliberate decision to, cut somewhere. And so that's the approach in FHIR. Obviously, you have to recognise that then, everybody will be missing something. So we have a nice, discoverable and documentable way of adding your own chunks of FHIR. So every FHIR resource allows you to put a little extension chunk on the top, and it always uses the same tag, so you'll always know where to find it. And you can label it with the name of your institution, your specification, a nice URL that says, well, it's so-and-so hospital / FHIR / Swedish middle name, or German apartment number, whatever it is that you specifically need that doesn't commonly exist everywhere else. Version 2, going back in the day, it had these Z segments or Z segments. A similar idea in a way, but because that was pre-internet and there was no way of registering these or finding or clicking on the URL to see the definition, it tended to fragment and nothing was common. So FHIR extensions, you can find other people's extensions. So if you know that it's common to add an extra feature, you can find it and share extensions. So that's our mechanism for getting around this fact that you don't want to boil the ocean and have everything in FHIR. So a couple of things, profiles are where you take FHIR and you say, well, I'm going to use this subset of FHIR in my interface. So although FHIR is designed to be compact and small, the 80%, you might only need the 40% in your department. So you can say, well, we're not going to use this, this, and this. We're just going to use this. You can package that up in a profile and say, this is our little exchange contract in our department. This is our profile of FHIR. So profiles are for making things smaller and saying which slice of FHIR you're using, and extensions are where you add bits to FHIR. And they kind of work together to tailor FHIR to your specific needs. So these should be familiar. All modern stuff works on this. We saw that Google, Facebook, all these APIs work this way. So the REST API here, it's a strange acronym, and but it refers to a way of working where your data is exposed as a series of web pages. Yeah, so it makes it highly scalable because nothing scales like the internet. There's lots of technology in there. It seems a strange way of exposing your data, but it is highly flexible and scalable and fast and so on. And then in turn that uses HTTP because the HTTP is the language of the web and the protocol of the web. And we support XML for old-timers like me, but the kids use JSON these days. There's also RDF. It's kind of at a slightly research phase, the RDF support, but the idea being that FHIR is not restricted to any particular syntax. It's a flexible model that can be represented in different ways. It has the data types, so the nuts and bolts, the strings, the addresses, the codes, and so on. And they're based on the W3C set, so that's as kind of basic and common as you can get. FHIR doesn't reinvent security. We have HTTPS certificates and things like OAuth, where you trusted authentication and so on. FHIR lets those existing standards work on top of it. It doesn't try and reinvent that. So we're not the security guys, but we know how to work with those security guys. So resources, mentioned this a few times. It's a key thing, and these are our little building blocks. So imagine you have a diagnostic report. So that's the patient's had some tests, and the blood has been analysed, and the results have been computed, and you have a little structure, a diagnostic report resource in FHIR where you put those bits of information. But you can't do much with a report format without saying who it's about. So we have a patient resource. It's kind of our number one, obvious, most used resource, of course. Patients have next of kin and people that you might want to phone if they need some help and so on. So related persons, location, where the diagnostic report, the lab, whatever, physical location, in fact, and then who did the test, maybe who authored the report and so on. So these are our little chunks. FHIR builds these resources, plugs the resources together to form a kind of interconnecting health record, or in this case, those 4 or 5 make the report. Yeah, so that's the kind of components of the report. There'll be observations in there for the actual numbers and so on as well, the actual values. So these resources, come back to them again. They're our content model. They're the chunks of, they're what makes FHIR, if you like. They're where your data items go. It's the R in FHIR. They're the things that are exchanged. So they're kind of the units of exchange. So FHIR has this web page-oriented view of the world. So you will see a chunk of patient data, and you can read that from the server or write that to the server. You'll see a location record. You read and write that. So those are our kind of units of interoperability. They're the chunks. You can't save half a patient. You can't, without using some special features. You wouldn't just update the patient's name. You tend to download the patient, have those 30 or 40 fields, and upload the patient again afterwards. So you've got this kind of page-based metaphor, if you like. Yeah. So resources are our chunks, our units of interoperability. We talked a bit about the past, how we built on version 2 and 3 and so on, and inspiration from those. And yeah, we can, resources are not tied to any particular syntax. And we have a human readable section. So one of the lessons of CDA, I don't know if any of you guys know CDA, but it's the kind of HL7 document standard for discharge letters and medical summaries and so on. That was a reasonably successful version of HL7 version 3, CDA. It's almost kind of like the PDF of healthcare to some respects. So one of the good things about that was it has a human readable section, kind of pseudo HTML in fact, and even if your system doesn't support LOINC codes or SNOMED or whatever, you've always got the text to fall back on. So FHIR brings that forward. So we like to think FHIR is simple, but there always can be an XHTML section in the top of your resource that any device can render. Yeah, so I mean your kettle, your fridge, probably your car stereo has an HTML library in there. So all systems can render a piece of FHIR, even if they're not that familiar with that resource. And we mentioned extensions and profiles. But let's see a resource. So our kind of go-to resource, patient. This is the kind of size we're talking about. So hopefully it's understandable, sensible names. It's called patient. If you look at the XML, it's not lots of nested levels of generated names, and you can see fields you'd expect, names and dates of birth and so on. And you can get your head around it. It's a one page. What's that, like 40, maybe less than that, 25, 30 fields, something manageable. And that's the current proposed normative version of patient going forward. So this is a kind of the size and shape of things. It's something you can deal with. So what are resources? Well, the ones on the left are our examples of things you find in FHIR. These are just headings. They're not actual resources, but they're categories. So we've got patients, practitioners. As I say, they're the nouns and the building blocks. Might correspond to the tables in your database, possibly. The classes in your object-oriented program. So we've got our admin stuff. We've got our clinical concepts, allergies, conditions, encounters, and so on. FHIR also has some bits that it kind of uses to make FHIR itself work. So things like composition. The composition resource, as it might suggest, is for building documents. So if you're trying to do a letter, you're trying to perhaps mimic something that's an old-fashioned paper flow, because clinical data moves in sort of paper-oriented ways in some places. You can build a composition resource that tells you who wrote the document and which sections it has in it and so on. You combine that with a patient resource and maybe maybe an allergy resource, and you can have a discharge summary that says patient was found to be allergic to so-and-so. So the composition resource represents a medical document. We have a message header resource. So if you want to do message style data exchange rather than web-based, you can use, you will need to say, well, which system is sending, which system is receiving, so that we have a resource that kind of mimics the HL7 version 2 MSH segment, perhaps. Yeah. So FHIR has these ways of using resources as kind of infrastructural things. Also, things like capability statement. So that's a piece of FHIR machinery that lets you describe your server and which resources you support and which version of FHIR you support. So you can go to any server and read the capability statement. That's the one thing that the server has to support, is its statement of what the server supports. And it will say, well, we only support patients because we're not a clinical system. Maybe we're an admin system or an appointment system. Maybe we're read-only. Maybe we're a directory of providers, but you can't update it because we're not clinical. So maybe we support all systems, different versions of FHIR, and we support XML, but not JSON. So all these things are listed in a machine-readable way, which is quite neat. And it also even lets you do some automated testing. So you can write software that will interrogate the server, see which resources it supports, run them against your schema checker, and so on. So there's some nice automatic way of finding things. Some counterexamples. So gender is a kind of below patient level field. That's too small for a resource. It's a property of a resource rather than a resource in its own right. The whole health record would not, in EHR, that would not be a resource. It would be a collection of perhaps a couple of dozen types of resource and thousands or millions of instances of resource. So that's built of many resources. Blood pressure is interesting because FHIR does not have a blood pressure resource, and it does not have a BMI resource or a broken leg resource or any of these things, because FHIR, like other standards before, has this idea of the objects of data on one side and the codes and the terminology on the other. Yeah, so FHIR doesn't create a resource for every SNOMED code or every RX norm code or whichever system you use in your countries. FHIR works with the terminologies as usual. So you have an observation resource, you plug in a LOINC code or a SNOMED code, of course, and then the combination makes a blood pressure resource with 2 values and so on. So FHIR doesn't have resources for every medical concept. It uses terminology, and other people build those for us. So multiple resources are needed to kind of get the job done. We saw our diagnostic report earlier. And here's another little example. So a set of resources, and so a procedure that's been done for a patient. And you can see that the 5 resources around the edge, familiar concepts, conditions, encounters, and so on. And each arrow, each connecting line, and these represent the connections between the actual FHIR resources in the data. The resources have a kind of context. So here the patient is the subject of the procedure. In theory, the patient could be the person who did the procedure. If it was, removing your own stitches or something, you could, in theory, or taking your own medicine, the patient could be the performer. But in here, we have a practitioner as the performer. We have an encounter. The encounter is just the encounter. And we have a report that the procedure was, documented in. So a collection of resources, contextualized with the links between them, that builds up your record, or your record of what procedure was done to this patient. So I don't know how legible that is at the back, but it's this is your kind of first taste of XML. And the details are not so important, but really the idea is the stuff on the left here. You can see some of the parts of resources. So resources have a few different areas. It's almost good to start with the bottom here. So this chunk here, a little bit hard to see, but you've got identifiers, name, and gender. So these are the common bits of patients you expect to see. They're called out on the right there. So the lower part of the resource is actually the data that you're expecting to see for a patient. And then we have some other interesting parts. So jumping back to the top, we have, well, at the very top it says the word patient. So you can see a patient tag here, and it's got a FHIR namespace, if those that you can see that, just telling you it's XML in FHIR. And we have some metadata. So we have an ID. So the ID here, and that's interesting to contrast that with the identifier here. We'll come back to that in a moment. This is the kind of the record location. It's where you would go to find this record. Yeah. So this isn't the patient's social security number or their driver's license or medical record number. It's kind of the record location. We'll show you how that works in a moment. And then some other metadata when this record was updated. So that's not a feature of the patient. It's a feature of the record about the patient. So we have some metadata in our record. We have our text block here, so you can see, it might not be easy to see, but you have some text and XHTML, and that's in a different namespace, so you can your code can immediately go to that chunk and display that if it wants to do a simple rendering. So some nice human readable comes quite early on. And then another interesting thing here is this extension. So this resource has been extended for what is seen as a missing feature for this implementation. And you might be able to make out it's got a long name, FHIR structure definition, US core birth sex. So there's a standardized extension that some guys in the US have done for the sex of the patient at birth, which could in theory be different from the gender later on. So that's not that widely used a concept, so it's not in the core 80%, but it's a useful feature. Some records need that. So yes, it's the patient resource, so some metadata, text, the body at the bottom there, and extensions. They come at the top, interestingly, due to some technical reasons why they come at the top rather than you might expect extensions to be extended at the bottom, but it means it's harder to miss them as well. Yeah. So that's some more XML. That's about as technical as we get today. But of course, JSON is really what a lot of people use these days. Exactly the same four sections, same XHTML. So you've got some evil angle brackets in the middle of your nice curly brackets for those of you who like JSON. But all the same stuff, just with that different syntactic sugar. So we've talked about REST briefly, and even if you guys have not heard of REST and the web-based way of reading data, your technical guys will have, I'm sure. This is how you would find the patient resource with ID 1234. Yeah? So that's not social security number 1234, it's record location 1234. So it's what was the ID at the top of the previous slide. Yeah? So what we're saying here, I mean, this looks like a web address, doesn't it? I mean, it is a web address. It's a URL. You could even go to that with your browser, browse to that. Well, it's not a real one, of course, but you could browse there. It's a secure thing, so you probably wouldn't see anything if it was, unless you had the credentials. And you would see your browser would be returned a chunk of JSON or XML. Yeah, so a human could actually go and browse to that, assuming they had permission, of course, and so on. But of course, we don't normally use browsers for our real data, but the same libraries, the same code inside your browser that speaks HTTP, that code can go to this endpoint and read that data in a kind of web-oriented way. So that's kind of our RESTful way of working. It's treating your data records as if they were a series of web pages. Yeah? And when we saw the links between resources, you think, well, in terms of the web, well, they're hyperlinks. So your connected resources in FHIR are a series of kind of hyperlinked chunks of data. So when you pull back this page of data, which would end up looking like this, you can see a reference here. So down at the very bottom, probably hard to see, but it says reference organization example. So the patient has a kind of hyperlink to the organization that controls that patient. So you're already starting to see this one page for the patient, hyperlink to the organization, another page. So a page-oriented view of your data. And that's a real mind shift with FHIR. We're not so much always talking about, I send you some data, you acknowledge and reply. I'm not sending you a chunk of PDF. You kind of post up your data and make it available as a kind of website, so people can just come to your site and query and look for patient data. So it's almost like you're hosting a series of web pages of your data. It's a strange concept, but it's quite a powerful one. So that would probably give XML. If you don't specify, you probably get XML back from that, but the default is up to the server. If you wanted JSON, you can see how on the end of the URL, you can build up commands. So we know which server it is. We know it's the FHIR part of the server. All of this is completely up to you. That could be myhospital.org/version2, whatever. This is a keyword in FHIR. You have to use patient, and it has to be capital P, because that's the way it goes. This is your ID. It wouldn't be 1, 2, 3, 4. It would probably be a much longer thing, really. But then you can start to add on commands. Yeah, you might see these when you go into Amazon or something. You type something, and you see the next URL comes back with an extended bit of chunk on it. You know there's something going on there. You can put little commands in. So format JSON. It's the same page, but you're asking for that page to come back in a different format. Yeah. So you start to think that the data is not really in either XML or JSON. The data is just in some almost like virtual format, and you can ask for the same page in XML or JSON or RDF or some new format that comes along in future. So you're already starting to think, well, the data probably isn't in any of those formats. Yeah, the data is probably in SQL, really. It's probably in my Oracle or SQL Server or MySQL database. You're asking for a view on that data, and it will probably be converted to FHIR format and JSON on the fly. Yeah. So that's another thing. Your data is not necessarily natively in FHIR at all. And then that extends for sort of more searching. So you can, the similar kind of question mark syntax, you can sort of start to say, well, give me the patient's name, Smith. You'll notice that we don't specify the ID. So that's a specific patient and a format. Here we're saying, just look at all the patients and give me the ones called Smith. Yeah, and that will return you a search set of 0 hits if there's nobody, or 1 or 1,000 hits, depending on what happens. We mentioned these two types of ID. So you've got the ID as in the record location, called the Restful ID. So it's which page is this data on? Yeah, a patient could be on a different page on this server and on this server. The same data could be hosted in different places, because that's just a record level thing, an IT level thing. Yeah, so it's metadata. It's not really the patient's business. It's about the patient. Then we have identifiers. Patients you need to know who they are. You need to know their medical record number, their departmental number, their national security number, whatever. So there's very much two types of identifier in FHIR. And you can work with both. So here, you notice we're not doing the /1234, but instead we've got the question mark. So we're querying on a different field, and we're saying, give me the guy with, or lady with identifier medical record number 456, yeah, which could be your local hospital thing. So you can query and find patients. You don't need to know their FHIR record number in order to find them. And you can add on a little comment here. You might have multiple ways of numbering your patients. Maybe the internal number, the external number, the national health number. So you can prefix that with NHS number : and it will find the people who have that sort of number in that format. Okay, so that's a little view of data, the actual XML. But one of the good things about FHIR, the code exists, but also servers exist. There's already plenty of servers out there that you can play with the data for all different versions of FHIR. So if you, that's a long URL, but if you Google public FHIR servers, it's always the top hit. It's always been the top hit forever, and you can see some more or less official and servers. You can just use those URLs. So the URLs you saw before, patient /1234, you can just go on there, type with Chrome or whatever, and you'll see data coming back, and you can click on the hyperlink and go to the next page and so on. It's a good way to learn. And it's a good way to test your code. When you're writing a little FHIR client to pull some data, you can be sure that if you can read from those servers, then you're on the right lines. So we've mostly talked about REST so far, but I also mentioned that FHIR supports these 4 ways of working, because not everybody is ready for a move into the kind of web-based way of working. You may have infrastructure that you need to work with existing. So REST is kind of where FHIR really majors, and it uses the HTTP standard, and that behind the scenes does GET and POST. So when you read some data, or you fill in your details on some web page and you hit go, you hit send. That behind the scenes, that's doing a post. So with HTTP and the web-based way of working, you can do all your database access. You create, read, update, delete. You can do that over your HTTP. And once you've got those together, that gives you kind of all the kind of verbs you need to get your data working. But as I mentioned before, there's a composition resource that lets you join resources together, bundle them together. In this grouper, FHIR has a grouper called a bundle, which is another infrastructural grouping thing. It lets you make document-like things to mimic the slightly older way of working, traditional perhaps. Messaging, we can also do version 2 style messaging with our message header resource we mentioned. Call and response, store and forward, this kind of version 2 sort of way of working. We find these are not used quite as much as the RESTful way of working, but some people need that. SOA, so this is kind of what came before REST, really. Some very complicated remote procedure calls over the web, SOAP and so on. That's perhaps the least used version of FHIR because FHIR was almost a bit of a reaction against SOAP and the complicated payloads. FHIR is a kind of a RESTful and slightly simplified way of exchanging. So less people are using that perhaps. But the key thing is the resources are the same. Yeah, the same chunks, the same formats can be in your main server. It says facade on there because your server may look like FHIR, but really behind the scenes it's your old-fashioned database, mumps or whatever, and you just transform to FHIR. So it appears to be FHIR, but isn't really. Your lab system might have a backbone, a messaging backbone, sending in FHIR messages. And then you have a new, nice, shiny iPad application on the wards where the practitioner can see the lab results using his browser-based view on your server. And then you can package it up. Maybe your national body wants reports about some lab tests that are in a certain range or something, but it only accepts XDS-style documents or something. But the point is the same jigsaw pieces are the same. So your code that generates those little chunks and adapts to those chunks can be wrapped up in different ways. So nearly at the end, but some pointers. The FHIR spec is there. That's the URL. The resources are right there in the top. These nice introductions, these are good. These 2 or 3, often overlooked, but introduction for developers and clinicians, these are worth reading. The RESTful API is a good place to start to understand how this page orientation is working. There's multiple versions of FHIR. We're on our STU3 here. It's a couple of years old, but the 4 one is coming up. That was the latest draft, so R4 is coming up soon. These are just some of the places you can look into, going deeply into the RESTful API, see how individual updates work and so on. Using the put there, an HTTP put is how you would update data. You can click onto, we saw the UML view before of the patients. That was the one I showed before, but on the different tab you see a structured view and you can dive in, click through. It's nicely documented. Read about the data types behind. So the name on the left is a human name object. And then you can dive into the data types here and see that right down to the bottom. That's kind of like the lowest level. You see your booleans, integers, and so on. That's a view of the resource page, and you'll see FHIR is an evolving standard. So normative, it's kind of level 6, is where we're trying to get to right now. A lot of FHIR is still draft, and you can see the different numbers against the different resources that tell you how draft and how baked it all is. We mentioned capability statement as our infrastructural thing. That's the way that a server tells you which version of FHIR it's up to and which resources and what level they're at. Another piece of infrastructure, for those of you who are more technical, FHIR describes itself in a resource. So the structure definition resource is a resource that's used to sort of document how the resources work. So it's kind of like the source code for FHIR. So those of you who are doing code generation and things like that can go right deep in there. And as I say, so we've been we keep saying FHIR is new, but FHIR is now sort of 6-7 years old, so not so new. And the first normative finished version is kind of real soon now, so December, January time. So last slide, recap. We've got our resources. Extensions. You need extensions. They're a fact of life. Embrace them. We talked a bit about profiles, bundles for documents and so on. Our syntax is human readable, XHTML chunk, and some machine readable parts of FHIR to describe it, paradigms. And yeah, the documentation is good. It's a real strength of FHIR is that the HTML, it's the first HTML era version of HL7 standards. It's good to click through. And that's my last slide. So thanks for listening. If there's any quick questions, feel free. Stunned you all into silence. Maybe you've not had a coffee yet. So yeah. Oh yeah, hi.
So I'm Dave DeBronkart. I'm here from the patient perspective.
Okay.
I've worked on standards in the past in other industries.
Right.
I want to heap praise on you for the clarity of this. Extremely.
Thank you.
well done.
Many of these slides are from many of our colleagues. It's a very much team effort, but thank you. Yeah.
And also in looking at that slide that had developers introduction and various other.
Oh, right. Yeah.
I
Yeah,
proposed
this
to
guy.
Graham the other day that what we next want to add is a patient's introduction.
Right. Yeah. That's a good. Yeah.
And he said, let's talk
That's a
about
good
that
idea,
in
actually.
Amsterdam.
That's a good idea. What does FHIR mean? Yeah, that's a good idea because
Yeah,
not a
because
non-technical.
There are people
Yeah.
like this guy, Michael Morris, who's starting to do their own
Right.
coding.
Okay. All right. Okay. So you're like a patient advocate, or you represent?
Yeah, I'm an advocate for patient involvement in
Right.
everything.
Right. Yeah. Good. Yeah, good to hear. That's a great idea. Yeah. Good idea. Yeah. Okay. Any more? All right. Well, thanks again. Enjoy whatever you go to next, and I'll see you in the halls or somewhere. Yeah. You can chat to me at breaks, or whatever, if you like to. Thank you. Thanks.